In this video we will see about naive Bayes classifier. Okay, the whole idea is how can we utilize Bayes theorem for classification. So we will see what is Bayes theorem here. Probability of B given A is equal to probability of A given B into probability of B by probability of A. Okay, so how this equation can be useful for classification? For that we'll first look at this term. This is called as posterior probability. Okay, posterior probability. So we are supposed to calculate the posterior probability. But how this posterior probability can be useful for classification? So here we'll read this as probability of B given A. Okay, if we look at the classification task, we have a sample. Given the sample, predict the label, right? So here we are trying to map this to this particular posterior probability. Probability of B equal to some class S given sample A. I can read this. Probability of B given A. For classification, A is a sample and B will be one of the label. Okay, one of the label. So if we are doing binary classification, we are going to have two posterior probabilities. Okay, two posterior probabilities. Probability of yes class, and we also have no class probability. Okay, given the sample A. For both the classes we are going to calculate the posterior probability values and we'll decide the label based on the probability values. If the probability of yes class is greater than the probability of sample belongs to no class, then we conclude that sample A belongs to yes class. Okay. If it happens in a reverse manner, like if probability of yes class is less than probability of no class, then sample A belongs to no class. Okay, but to do the classification, we are supposed to calculate this posterior probability. We can calculate the posterior probability based on these three terms. Okay, this term we call it as likelihood. Okay, likelihood. This term we call it as prior probability. And this we call it as evidence or marginal probability. Okay, so based on these values we can get the posterior probability of sample belongs to a particular class. Posterior probability of sample belonging to a particular class. Okay, but what is this likelihood, prior probability and posterior probability, evidence and margin? All are probabilities only, right? All are probabilities only. Then what is the difference between this posterior probability, likelihood, prior, etc.? How can I differentiate these terms and how can I calculate posterior probability? That's the major doubt, right? So to understand these, we look into an example. We will look into an example, real-time example. Okay. consider that you wanted to go for shopping. Okay, you are going for shopping to get a dress. Okay, you wanted to buy a dress, and for that you are going for the shopping. So you have taken your vehicle and started to the shop. Okay, so now you reached the shop. As soon as you reached the shop, and outside of the shop you can observe some flexi like flat 50% discount. Okay, flat 50% discount. So you have observed that flexi outside the shop, and you thought like you can buy your dress at cheaper cost. Okay, and you entered into the shop. So the display, you are having a display of dresses, and you have seen, okay, and you have seen the dresses, and you have selected one of the dress. You have picked one of the dress, and you went to the salesperson there who is standing. Okay, you went to that salesperson and you have given the dress, and now you are asking for the discount. Okay, now you are asking for the discount, like 50% discount I have seen outside. So I need the discount. So now what salesperson does is he takes the dress that you have given, and he will look at these two. Let us tell this as shelf 1 and this as shelf 2. So now he looks at these two shelves and he identifies from where you have picked that dress. Okay, so once he identifies, then he'll start explaining you for which dresses the discount will be given and for which dresses the discount won't be given. So now if he says that the shelf 2 dresses that are displayed are unique collections, okay, so on that there are no discounts given, you have to get it for MRP. Okay, but if you want discount only, then you can choose some dress from shelf 1. That's your choice, whether if you want to offer for MRP you can take this dress, or if you want to go for discount you can choose some dress from shelf 1, right? He will suggest you. How this scenario is useful for us, okay, that we will see. Why we are discussing this scenario is to understand the difference between likelihood, prior probability and posterior probability. Okay, for that, what is prior probability? As soon as you have came to shop, outside you have seen that flexi, right? Flat 50% discount. Okay, so it means that you got some information from the shop that you have certain dresses with 50% discount. Okay, there are certain dresses with 50% discount. That information you know. Okay, irrespective of which dresses those are, you have that information that 50% offer is there. So that information is called prior probability, prior information. Then once you have selected a dress and given to the salesperson, now he is going to find from which shelf you have taken this. How he is finding? Based on the similarity of the dress type. Okay, suppose if shelf 1, if you are trying to buy a shirt, if shelf 1 is having t-shirts and shelf 2 is having some what we say official wear, then what happens is he will try to identify, and because these are official wears and are unique, you can't get the discount. That is what he said. So it means that he is trying to find the similarity of dress type here, right? So the finding of dress similarity of dress type, and he will decide the similar dresses are not having discount, so this dress is also not getting any discount, you have to buy it for MRP. So it means that likelihood how many dresses are similar to this dress and not getting the discount? That is likelihood probability, right? Okay. And next, posterior probability. Posterior probability, what it is? So now once he finds the similarity, then he concludes that this dress is not going to have the discount. The particular dress that you have selected is not going to have a discount, or it is going to have a discount, whatever he says. The discount is there or it is not there. That information, that finally whatever, for the sample that you have given, for the dress that you have given, he is concluding that discount is not there. Okay, that is posterior probability. For likelihood, he is trying to identify the similar dresses that doesn't have the discount. Okay, so that is likelihood probability. Posterior is for your particular dress that you have, for the dress that you have selected, for that one, whether the discount is given or not. Okay, I hope you understand the difference between these three probabilities. And if you are clear with these three probabilities, now you can play with Naive Bayes classification problem. Okay, so here so with this we tried to understand this equation and the basics of Naive Bayes, and the differentiation between prior, likelihood and posterior is being discussed in this video. And in the next video we will discuss about Naive Bayes. Here we have seen only Bayes theorem and the difference between those probabilities, but we'll discuss about Naive Bayes, what is the term naive means, and how can we do classification on the given data set. That we will see. Okay, but now I wanted to conclude this video with two different questions. Question 1, what happens if probability of S class, posterior probability of S class is equal to posterior probability of no class for sample A? What happens? And can we, so in this video we have seen binary classification with we have took completely binary classification example, right? Can we do this for multi-class classification? Yeah, think about this and try to comment your answers, and we'll see different problems and we will go in deeper into Naive Bayes classifier in coming videos. Thanks for watching.